Okay, so we set the derivative of velocity with respect to the trachea during coughing. It's a 0. And let's see. I'll just write it down, then we'll decide what to do. Anyone have an idea? Okay, so factor out, whoops, not the 2, but we'll factor out the k and small r. Okay, so I have 2 capital R minus 3k small r. Not the k. Good. That's not okay. Okay, how about that? Sorry. So now we've got 2 factors set equal to 0. What do you know about 2 factors set equal to 0? 1 has to be 0. Or, so, what am I trying to find? Okay, I want to find what radius, what constricted radius is going to produce the maximum air velocity. So I have that when the radius is 0, think about it. Think about it. Is it possible? What happens to you when your trachea constricts to 0 radius? You kind of can't breathe, right? Is that a good thing? No. Okay, you're not. Now remember, we're going for maximum. We're not saying which one's maximum, which one's minimum, right? If your trachea has constricted down to nothing, it's completely closed, is that going to be your maximum air velocity? Or is that going to be your minimum? Minimum, okay? So, that's not going to work. Over here we have that 2 cap r equals 3 small r. R is 2/3 cap r. So what's going to give you maximum air velocity? What's capital R stand for? Yeah. So if you can constrict now I want you, next time you cough, I want you to do this on purpose. Constrict your trachea to 2/3 of its normal size. And you're going to have maximum air velocity. Okay. Well, there's no way I can graph that for you because I don't know what normal is. What is it? I don't know. Figure out. Half an inch? No, it can't be half an inch. That's not an inch across. Maybe it is. Okay. Anyway, that's what we're talking about. That's the whole gist of that problem. Now, everything we're talking about is we now know how to take derivatives. Chapter 2 is all about how do you take derivatives. We talked a little bit about the applications and so forth, but we really were just in the process of taking derivatives. Chapter 3, we're beginning now, and we're going to spend the rest of the course talking about, so what? Where can we use this? How can it be used? Here's an example. We are given a situation where we have a formula for it. We have a function that allows us to given an input, to figure an output, and we want now to maximize the value of that output variable. It's going to occur where the derivative is 0. Take the derivative, set it equal to 0, you've got it. There's a whole section coming up on optimization, and that whole section is going to be doing nothing more than problems like this. So hang on, those of you who are tired of just doing endless practice problems, we're going to have those where we can actually apply them. I'm going to stop this and go on now to section 3.3.